Okay, so we have SOHCAHTOA, right, which you probably know, but just to make sure, we have SOHCAHTOA, and what this is an acronym to allow you to remember the trig ratios. Sine, S-I-N, opposite hypotenuse, that means sine of the angle is equal to the length of the opposite side divided by the length of the hypotenuse, and CA means cosine of the angle is equal to the length of the adjacent side divided by the length of the hypotenuse, and TOA means tangent of the angle is equal to the length of the opposite side divided by the length of the adjacent side. And the reason why this works is because with every right triangle, you have your 90-degree angle, and the relationships of the sides are exactly the same in ratio. So whether I'm talking about a triangle that is 3 inches square, or whether I'm talking about the relationship between stars or, you know, a football field or a gigantic building, the ratios of the angles created are always the same. That's why we can use this SOHCAHTOA, okay? And the opposite and adjacent are relative. In other words, if I'm talking about this theta, that is the opposite side of that angle. That's the opposite to that angle. The adjacent means next to it. So this is the side that's next to it. The side opposite the hypotenuse or opposite the right angle is always the hypotenuse. Okay. Then next, and you can text me later with questions if you have questions. Next, we have special right triangles. And all this means is we have right triangles, and I'll start with the 30, 60, 90 first. Okay, so this special right triangle is a 30, 60, 90 triangle. That means that the relationship of the sides will always have this relationship. Opposite the 30 will be x, opposite the 60 will be x root 3, and opposite the 90 will be 2x. What that means for us is opposite, hold on one second. Okay, hold on one second. Time out. Okay. All right, so in this case, we're going to think of it as a 1, 2, root 3. So in this case, I have 1 opposite the 30, I have root 3 opposite the 60, and I have 2 opposite the hypotenuse. I will go over this, and I will use this when we get to your exact questions, okay? Next, we have our 45, 45, 90 triangle. And what we have here is opposite the 45 is the square root of 2. We could multiply that by x if we'd like. Opposite this 45 is going to be the same distance, root 42. My hypotenuse is 2. So there's going to be a little bit more involved in this with different problems as well. But again, the relationship is simply root 2 over 2. Okay? All right. So that's SOHCAHTOA. All right. Now, this is where you will distinguish between so what we're talking about here is the positive, negative aspects of sine, cosine, and tangent. And the first thing we need to understand is that cosine is our x variable, sine is our y variable, and tangent is the relationship or the ratio between y and x. What that means is, in the first quadrant, everything is positive because x and y are always positive in the first quadrant. So just coordinate points, 3, 7, or whatever it happens to be, everything is positive in the first quadrant. Therefore, every trig ratio, sine, cosine, and tangent, and the other 3 you won't do yet, are all positive. They always come out positive. So sine of 45 will be positive. Cosine of 60 will be positive. Okay? Secondly, in the second quadrant, remember we go 1 to here, cosine is negative and tangent is negative. The reason tangent is negative is because we're talking about the ratio. So if my x, which is my cosine, is negative, and my y is positive, then tangent has to be negative. All right? So in the second quadrant, cosine is negative and tangent is negative. In the third quadrant, going negative, negative, in the third quadrant. Cosine and sine are both negative. But because I'm dividing y by x, and they're both negative, tangent is positive. All right? And again, I'm not going into the other three ratios. We'll get with those later. But cosine and sine are both negative. So if I say to you cosine of 210 degrees, you know your answer is going to be negative. Sine of 240 degrees, you know your answer is going to be negative because it's between 180 and 270. All right? And tangent is the relationship between those two. And because I'm dividing a negative by a negative, it's going to be positive. Okay. Lastly, in the fourth quadrant, sine and tangent are both negative because sine, remember, is my y value. It's below the x-axis, so that's negative. And tangent is the relationship where x is positive and y is negative, therefore tangent is also negative. Okay, that's why they are negative. This is a really easy way to remember it. All students, there's my sine, right? The S stands for my sine. Take, that's my T is my tangent. Calculus, cosine. All are positive. Sine is positive. Tangent is positive. Cosine is positive. But I really, really, really think it's important for you to recognize as the exact y, which is the idea of the x and y values. Okay? The reason we're going over this is so important, is because of the next thing, which is the reference angle. And the reference angle, I don't know if you know the word, I don't know if we're never, but what it is it really is equivalent to the distance to the x-axis. That's Danny. So the distance to the x-axis. So if I have a 30-degree angle, I'm only using 30 as an example, right? That means sine of 30, which equals 1/2, right? That means sine of 150, because my reference angle is 30, is going to be 1/2. And that means sine of 210, and the reason it's 210 is because if I go all the way around from here, so these pink lines right here are referencing going all the way from this axis. So if I go all the way to here, which is 210 degrees, I'm going to create a 30-degree reference angle. And by reference angle, I am talking about the distance from the x-axis. Reference angle is the shortest distance to the x-axis. Okay? So in this case right here, if I go 210 degrees, my line's going to be right here, and my reference angle is going to be 30 degrees. What that means is sine of 210 is equal to not positive 1/2, but negative 1/2, because remember, sine is negative in the third quadrant. And lastly, sine of 330 degrees. Again, that means I'm rotating all the way from here all the way to there. That's 330-degree rotation. And again, my distance to the x-axis is still 30 degrees. That means my reference angle is 30 degrees. That means sine of 330 is going to be negative 1/2. And the reason that is because it creates a triangle. We'll talk about that at a different time if you want. It creates a triangle that has the same ratio of sides. The only thing I need to concern myself with is I am in the fourth quadrant. All right, I'm in the fourth quadrant, and in the fourth quadrant, we know sine is negative. And we know sine is negative in the fourth quadrant because we know that sine deals with our y value. All right? And I'm only giving you this example, sine, because I just chose sine. If I chose cosine of 30 degrees is equal to root 3 over 2. We'll talk about that in a second when it comes to our triangles. Therefore, cosine of 150 is going to be my 30-degree angle. Remember, it's in the second quadrant where cosine is negative, so this is going to be negative root 3 over 2. Cosine of 210 is going to be, it's in the third quadrant. We know cosine is negative in the third quadrant. Negative root 3 over 2. And cosine of 330, again with our 30-degree reference angle, is going to be positive root 3 over 2 because it's in the fourth quadrant and x is positive in the fourth quadrant. So you're going to answer these in two ways. You're going to memorize some beginning functions, sine of 30, sine of 45, whatever. And then you're going to relate it to every quadrant thereafter, knowing where sine is positive and cosine is positive and so on and so forth, and the relationship of tangent. Okay, so we've done the SOHCAHTOA. Boom. We've done the reference angles. Boom. We've done the positive and negative. Boom. Now let's talk about your actual questions. So now I have two triangles that I drew out here, these black triangles. And your questions are tangent of 60 degrees. That's your first question, okay? Now, I'm going to, like I said on the text, I'm going to give you two ways to answer these. The first way I'm going to give you to answer these is the relationship of, in this case, sine over cosine. So, in fact, I'm going to come back to this one. Let's do, we'll fill this one in a second. Let's do, just for argument's sake, we're going to do two more. We're going to do sine of 60, and we're going to do cosine of 60. Now, we already did sine of 30, was 1/2. Sine of 60, remember, SOHCAHTOA. So we're talking about our opposite side divided by our hypotenuse. So we're talking about 60 degrees. Our opposite side is √3. And we're talking about our hypotenuse. Our hypotenuse is 2. So sine of 60 is square root of 3 over 2. Okay? Cosine of 60, remember co is ka, so it's the adjacent side, 1 divided by 2. So cosine of 60 is 1/2. And that is this value. I don't know if you hear the boys in the back yelling. Okay, so that's that value. So tangent of 60 is actually √3 over 2 divided by 1 over 2. In other words, my sine divided by my cosine, a little bit of magic algebra here, comes out to simply √3. So we know that tangent of 60 equals √3. The second question is sine of 225. And we're going to use this part down here to answer sine of 225. 225 is a 45-degree reference angle. You'll never see a 5 that isn't a perfect reference angle. So this is going to be, as sine of 45 is going to be, I'll give you those things to remember in a second, √2 over 2. If we went to sine of 45, we would go opposite over hypotenuse. That's sine of 45. And the reason we know we're using 45 here is because we know this is a 45-degree reference angle. We also know that this is in the third quadrant, therefore this is negative. So that's my sine of 225 is negative √2 over 2. We got 2 minutes left. Sine of 90 is just a memory. You just have to remember it. Sine of 90 is going to be the, it's going to be 1. I'll explain that to you at a different time. Sine of 90 is 1. Cosine of 150, we're going to go back up here again. The reason we're going to go back up here is because 150 is a 30-degree reference angle. Remember we talked about that before? So we're going to go 30 degrees, remember 30, because 150 is 30 degrees away from the x-axis. And we're going to go ka, we're going to go adjacent over hypotenuse, but from the 30 degrees, my adjacent is √3. And my hypotenuse still remains to be 2. So there's cosine of 150. Cosine of 90, if sine of 90 is 1, then cosine of 90 must be 0. We'll talk about that as well. Blah, blah, blah. And lastly, tangent of 240. We've already figured out the 60-degree tangent angle. Therefore, tangent of 240 is going to be a reference angle of 60 degrees. It's divisible by 60, which is another quick way to see if it's a reference angle, which means it's going to be √3. All right? And it means it's going to be positive since it's in the third quadrant. So positive √3. All right.